Today we are going to be looking at a video learning about confidence intervals and taking our knowledge of z-scores and standard deviation and using them to predict the future or to estimate things that will be likely to happen. This is done through, we'll look at a few examples. Balls used in sports have a specific expected masses, and the masses cannot be outside the specific range. Specified football has a mean mass of 14.5 grams, a margin of error of 0.5 grams, and a confidence interval of 9/10. So what this question is saying is that every time they make a football, it's going to be a little bit different. Sometimes it'll be bigger, smaller. For whatever reason, it won't be always exactly 14.5 grams, but that's what they want. They want them all to be 14.5 grams. But they're not all exactly 14.5 grams, so they say that so long as it's within half a gram, so if we think of 14.5, it could be half a gram less, so that would be down to 14, and half a gram more, 15. So they advertise that this ball is 14.5, but in reality, anything between 14.000 and 15.000 is going to be acceptable. So you may have some that are 14.3, some that are 14.8. All of these would be acceptable. The question is wondering, if they can only make this with a confidence of 9/10, what does that mean? How many do they have to throw away? So we're still going to be making these soccer balls about a normal distribution, and our average is 14.5 grams. 14.5 grams, and we don't know the standard deviation of this information, but we aren't getting into the specifics of that. What we do know is the margin of error. So down here somewhere, we don't know if it's 1 or 2 or 3 standard deviations, but down here somewhere is 14.0. And up here somewhere is 15.0. So in terms of our first two questions, what is the lower end of the confidence interval? That's 14. So the lower end, the lowest acceptable amount that we have is 14. And then what is the high end of our confidence interval? That's 15. What is our confidence level? That means how many of them are in the region, or if we remember, if we fill in this shape, the size of this shape, I really want us to keep that in mind. The size of this shape, or just this shape, actually represents all of the soccer balls, or footballs in this case, that are going to be good. What is our confidence level? Well, that is our confidence interval. So if 9 of 10 of them are good, 9 out of 10 is this region. That means that 9 divided by 10 is 0.9, or 90%. So our confidence level is 90%. So this green region is representing 90% of our data. 45% of the soccer balls are going to be heavier, but still acceptable, and 45% of the footballs will be lighter, but still acceptable. We can extend this a little bit further. 5% will end up being too heavy, and 5% will end up being too light. So how many balls are expected to be inside the confidence level? Well, if they make 90% of the balls correctly, we just need to find 90% of the total they make. So we'll squeeze it down here. Let's see, I gotta scroll down one more so you can see. So we made 7,000 soccer balls. How much is 90% of that? $6,300 soccer balls. I just realized now that my calculator that I was typing on you couldn't see, but here you have 7,000 times 0.9 is 6,300. So that would be the answer to how many balls are expected to be inside the confidence level. That's down here, which you can't see again. There we go. So that's the first question. We could also take this question to look at one more style of problem, and that is predicting, again, how many things will fall inside the confidence interval. and we're going to look at a manufacturer of smartphones. So a manufacturer of smartphone has created a new model, and the average life of this new model through their testing they determine is 48 months or 4 years, and it has a standard deviation of 12 months. The manufacturer is giving a 24-month warranty. How many phones are expected to malfunction during the warranty period? Okay, so what this question is saying is that the phone company recognizes that every phone that they make is a little bit different. Some will last a long time, some through manufacturing errors will just break early. They find that on average the phones last 48 months and has a standard deviation of 12. So if we do this, draw these bars in. So if our standard deviation is 12, one standard deviation down from 48 to 36, down to 24, down to 12. Then we could go up as well, 60, 72, 84. So this is the life of the phone, with half of the phones breaking before 48 months and half of the phones lasting more. The manufacturer will fix for free any phone that breaks under warranty. If they set the warranty to 4 years, they would have to fix half of the phones they sell for free. They don't want to do that. Right? If they set the warranty at 48 months, we know that this region is 50%. All of this together. They don't want to fix half the phones for free, so they want a shorter warranty. That's not that they think all the phones will break, but they don't want to fix them all. So they said their warranty is a 24-month warranty. So that means they're concerned with this region of our interval. They will fix any phone that breaks before 24 months. So if it broke at 10 or 12 or 20, that phone will get fixed. How many phones are in this region? Okay, this is where we're going to use our z-score information to figure out the percent. This was a number 2 standard deviations less than the average. So our z-score, we could use our z-score calculator to figure it out. First, let's do it like that. So our score that we're concerned about here, our raw score is 24. The average is 48, and our standard deviation was 12. So our z-score is -2. We can see here that our z-score from calculator.net is -2, and we should have expected that because z-score is a measure of how many standard deviations below we are. So -2, we are exactly 2 standard deviations below. Now that we have our z-score of -2, we can use our probability tables, or we could use this probability converter. So our answer is actually already right here, but I want to use the part below it, or this is where our answer is. But I want to use the part below because we're going to use it again coming up. So our z-score of -2, I'm going to put into the converter, because now the -2 technically is only just this line, right? -2 is saying where this line falls. This line is 2 standard deviations less than the average. So 24 is a z-score of -2. But now we're concerned about the region less than that, right? So that is this picture. We want the region less. There may be some questions where they ask how many are more than that, or between specific intervals like the next one coming up. But if we want the region less than our z-score, we would like the shaded in portion left of our line. And here we have our probability of what that is. Decimal 0.2275. So with a z of -2, this region has a probability of 0.02275, or in more manageable terms, 2.3%, about 2.275%. So this manufacturer can expect only 2% of the phones are going to break before 24 months. So about 2% of the phones they make will be repaired under warranty. All right, here we have the same question, just part B. Copied the first part in. And here they're asking, what percent of the phones are expected to malfunction during the second and the third year? So I'm going to start by redrawing our chart because we want to figure out what region we're talking about. So again, we'll draw in a few of these lines. Usually looks like this. Our average is still 48, 36, 24, 12, 60, 72, 84. All right, so our average is 48. This question we're looking at the manufacturer. What percent of phones is expected to malfunction during the second and third year of use? So the second year is going to be from 24 to 36 months. So this is the second year that you have your phone. Wait, no, that's not true. The second year you have your phone is going to be, because if we think down here, it would be 0. 0 to 12 is the first year you have your phone. 12 to 24 is the second year that you have your phone. And 24 to 36 is the third year you have your phone. That's better. Let's fill in these two regions. So this is the region that we're concerned about. From the end of the first year, from the start of the end of the first year to the end of the third year, or the start of the second year to the end of the third year. What percentage of phones are going to break in this region? I'm bad at drawing my braces here. There we go. So what percent falls in this region? This is where we're going to use a calculator to find different segments, or we can use the z-tables as well, and I'll talk about both of those. The first thing that we should do is determine the z-scores of our two boundaries. All right, the z-scores of our two boundaries. The left boundary here is our lower boundary. This is 1, 2, 3 z-scores away. And the right boundary is 1 z-score away. Okay, we could also use the calculator. This is 12, and our average is 48. So if we go back here, if we're wondering what the z-score for 12 is, or if we're given a value that's not a nice even whole, we could use our calculator. Just to confirm, our z-score is -3. So this is a z-score of -3. And again, we could calculate if we wanted to do 36. The 36 is a z-score of -1, just to be sure. The reason that now we want to use the converter, or want to think about this, is if we use the tables directly, the tables will only give us this whole shaded in region. We don't want this whole shaded in region. We only want a segment. So this is where using the converters can be the fastest, is we want to find the probability in between a z-score of -3 and -1. So we would like to find the probability between two z-scores. Z-score 1 was -3 and -1, and we can push calculate. 15.731. All right, and this looks like our shaded in region. So that's going to be the answer to our question. So the probability equals 0.15, was it 731? 731, or 15.7%. So they expect 15% of their phones to break between these two, between 12 months and 36 months. If we're using the table, if we're looking up the data, just to look at the other way, we'd have to find the probability for less than 3 and the probability for less than 1. So I'm just going to draw two quick charts like this. And how we would find it using the tables is first we would find our probability of z of less than -3. So that would be this region. So that is this guy here. We could find the probability when our z-score is -3. We did that up here. -3. So for just less than -3, this is 0.0013499. decimal 0.0134999. That is the size of this region. We would also find the size of our z equals -1 region. So that's going to be a bigger section like this. So z equals -1 we're going to put down here. And that probability is 15.866. Alright, so if we have the tables, if we're not using the calculator, in order to find the size of this shape, we first find the size of the bigger shape, and we subtract the size of the smaller shape. Because if we think about this, let's use like a red here. If we think of this being like, this being red, if we were to subtract it off, we'd be left with just the regions left, and we can see that 15.86 minus 0.013, if we subtract these two numbers, we're going to end up right where we were left off. So if you don't have the tables, or if you don't have the calculator, you can use the tables, but using the calculators is going to be much faster.